Hi, welcome to the Parallel Universe. In this video we will learn how to calculate net force for multiple charge distribution in order to solve numerical problems related to it. Before we move to the topic, we need to recall 3 points. Number 1, like charges repel, whereas unlike charges attract each other. Number 2, test charge is unit positive charge. And number 3, as per Coulomb's law, the electrostatic force between two stationary point charges is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance between them.
Let us consider Q1 and Q2 are the two charges placed at the two vertices of an equilateral triangle whose side is denoted by A. If we place a test charge Q at the another vertex, as shown in the figure, the force experienced by it due to both the charges will be the vector sum of the individual forces. Using Coulomb's law between the charges Q and Q1, we get the force F1. Similarly, the force between Q and Q2 is F2. In this case, both the charges are a distance apart from the test charge Q. After simplification, we will get the net force acting on the test charge as shown in the final expression.
Now, consider Q1, Q2, and Q3 are the three charges placed at the three vertices of an equilateral triangle whose side is denoted by A. If we place a test charge Q at the centroid, as shown in the figure, the force experienced by it due to all the three charges will be the vector sum of the individual forces. Using Coulomb's law between the charges Q and Q1, we get the force F1. Similarly, the force between Q and Q2 is F2 and the force between Q and Q3 is represented by F3. In this case, all the three charges are equal distance apart from the test charge Q. Using the basic geometry, we can calculate this distance is A by root 3. After simplification, we will get the net force acting on the test charge as shown in the final expression.
Another case where three charges are placed at the three corners of a square whose sides are denoted by A. If we place the test charge at the fourth corner of that square, it will experience the force due to all of them. Please note that two of the charges blue and green are a distance apart, whereas the red charge is placed at a root 2 from the test charge. Using superposition principle, we can calculate the force like previous approach.
Similarly, when four charges are placed at the four corners of a square, then the resultant force on test charge, which is placed at the centroid of the square, will be calculated as shown here. In this case, remember that all the four charges are equidistant from the test charge and the distance is A by root 2. That is half of the diagonal of the square.
If you have understood the concept, try to find the net force for the given figure, where 6 charges are placed at the 6 vertices of a regular hexagon. And the test charge is at the centroid. Give your answer in the comment section. Hope you find this video helpful. Please like, share, and subscribe to my channel for more such contents.